Hello Pre-Calculus kids. I wanted to today give you some examples from our practice problems that go with section 11.5. 11.5 is solving trig equations, and it is the last section in unit 11. So we're going to get ready for reviewing and having a test on this unit in the next little bit. So here are some example problems. I picked some of the ones I thought might be the more challenging ones of the crew. And you're looking at the directions here to figure out how you're going to be answering this. This one we're going to be looking at the column that has the pi answers when we finally get to our trying to figure out what x is. All right, so numbers 1, 2, and 3 are relatively straightforward. Number 3 you have to think about factoring. I would think factoring for number 3, but I showed you how to do that in the introduction, and you've seen some of those on the flip math video too. So I'm going for number 4 because look at that thing. That's very beastie. So here's what we're going to do. We need to get it into some kind of a format where I can solve for x. So I see two fractions that I'm trying to add together, and I need to get a common denominator between those. So I need a cosine of x, and I need a 1 plus the sine of x. All right, so this first fraction has the cosine of x. It does not have 1 plus sine of x. It needs the 1 plus sine of x, which means I have to FOIL this 1 plus sine of x with this 1 plus sine of x. 1 times 1 is 1, firsts. 1 times sine is sine. Sine times 1 is another sine. And sine times sine is sine squared. All right, that's my FOILage for the first one. Second fraction has the 1 plus sine of x. It needs the cosine of x. This guy I've got to multiply by cosine of x. Well, cosine times cosine is cosine squared. There's a plus sign there. All right, there's a trick to this one. Do you see it? Do you see it? Sine squared plus cosine squared. What do you know that that is? Hopefully you remember that that equals 1. So what I really have, if I kind of put my right-hand side together a little bit better, I have a 1 plus another 1 at the end, so I have 2. I have a sine of x plus another sine of x, so I have 2 of them as well. And it's still over this crazy denominator, cosine of x, 1 plus sine of x. Well, I kind of see that there's a very similarity between the 2 plus 2 sine of x and the 1 plus sine of x, except this guy, if I factor out a 2, then I would have a like grouping that I'll be able to cancel out. So that makes me very happy. That's what I'm going to do next, factor out a 2. Mr. Number 4 on the other side, he's just chillaxing, ain't nothing going on with him. If I factor out a 2, I get a 1 plus a sine of x. Distribute it back, you can check, 2 sine of x, yep, that's what it is. Over cosine of x and a 1 plus sine of x. And the thing that makes me happy about that at this point is that I can cancel these guys. All right, so what I'm left with is a 4 equals a 2 over a cosine of x. So a couple different ways you could go about this, but here's what I'm going to do just to keep it simple. I'm going to put the 4 over 1 and I'm going to cross multiply. So I get 4 cosine of x, 2 times 1 is 2, divide by 4, I get the cosine of x is 2/4 or 1/2. And that makes me kind of happy because I can go to my chart and figure out where is the cosine 1/2, and that's what I'm going to do next. So cosine is 1/2. Now remember from the directions they want it in pi language this time. So pi over 3 is one of my answers. X equals pi over 3. And is there anywhere else that the cosine is equal to 1/2? Let's see. Down here. And again, I'm choosing the pi language, not the degree language, because that's what the directions said. So 5 pi over 3 is my second answer for this guy. And there you go. So that one was kind of tricky with all the fraction work and such. The next one that I want to look at is number 8. Number 8 changed up the directions on us. Now we want our answer in degrees, so we've got to watch the column we're looking at for that. This one, number 7, I want you to think factoring. See how there's two terms? You've got a sine of x here, you have a 2 sine of x here. You can factor out a sine. So that's my hint for you for number 7. But number 8 is a little bit harder to do because see how I've got tangents and sines? They're not related at all. So it's going to be a little bit more interesting to figure out how I can go about making it so that I can solve for x this time. All goes back to your identities. So I know tangent from back in the day is equal to the sine over the cosine. Now, you know I'm a fan of cross multiplying, so let's try that with this one too. I have a sine times 1 is sine, and I have a negative 2 sine times cosine. I can't combine anything, it's just going to be a negative 2 sine cosine. So I'm looking at that, and that's the best I can do, but maybe I can pull everybody to the same side of the equal sign and think about factoring. So let's see what happens if I do that. I keep the sine of x here, I move this to the other side, now it's plus 2 sine of x cosine of x, and now it equals 0. So now it's like the equations that I've been looking at trying to work with. This one's a lot like this one over here, except this one's a minus sign and this one's a plus sign, so use the same idea when you go back to do number 7. I have two terms, both have signs, I can factor out a sine. Now if I take the sign away from this, I still need a placeholder there, so I have a 1 that's going to go there. I'll talk more about that in just a second. I have a 2 over here. If I factor this sign out, then it leaves me with just a cosine. Now let's distribute it and check and make sure we got the right stuff going on. So sine of x times 1 is sine of x. Sine of x times 2 cosine of x is 2 sine of x cosine of x. So I know I factored that out correctly. All right, so I'm going to take what I factored out, set it equal to 0, and I'm going to take what I have in the parentheses and set it equal to 0. All right, this one's already solved. Sine of x is 0. This one I want to bring the 1 to the other side. That means a cosine of x equals a negative 1/2. All right, so I'm going to go to my chart. I want to know where is the sine 0. Directions say I want to know in degrees. Where's the sine 0 in degrees? Here it is, at 0 and 360 and at 180. So my answer for this guy is that x equals 0, x equals 180, and x equals 360. Can I fit it in there? All right, those three places. Then I want to know where's the cosine equal to a negative 1/2. Well, a cosine equals a negative 1/2, and again I want my answer in degrees, so go back to your columns here. I want to know cosine is negative 1/2 at 120 and at 240. And so those are my two answers for this guy. X equals 120 and 240. All right, so there's number 8 completed. Oh, you can't see my answer there. There you go. All right, flip into the next page. There's a couple more that I want to do. First of all, and you might have seen this in the video, the flip math video, this one gets into the quadratic formula. We're not going to go there. That's really complicated, and we just don't need to go there. So you're going to skip number 10, just like there was one of the example problems that I put a skip on as well. You might have watched it in the video. It's fine, but you can see it was pretty complicated, and we're not going to get that deep. So I'm going to go to number 12, and if I look at the directions, I want degree answers between 0 and 360. So I'm looking at this, and I'm going to solve for tangent squared. I only have one trig function, so trying to get that by itself is going to be pretty easy. Tangent squared x divided by 16 is 5 over 16. I need to take the square rooty. I get the tangent of x. Anytime you take a square root, it's plus or minus, and it would be plus or minus the square root of 5 over 16. Well, that's not on your chart. Even if I were to take and simplify this, it'd be the square root of 5 over 4. That's still not on your chart. So what you need to do is go to your handy dandy calculator, and you need to figure out reference angles. I talked about this in the introduction video. So what you're going to do is you're going to take your calculator, and you want to know what is 5 divided by 16. So 5 divided by 16, it gives me 0.3125. But then I want to know what the square root of that is. So if I'm taking the square root of that thing, second x squared, I want the square root of 0.3125. And I get 0.559. So here's what I have now. The tangent of x equals plus or minus 0.559. I took 5 divided by 16, I took the square root of it, that's this number. I'm looking for the reference angle. I need to know what the reference angle is for this. So that means I'm going to take in my calculator and put in tangent to the -1 of 0.559. Now remember, we only put the positive part in. The positive and negatives tell us which quadrant we're going to put this in the end. So now second tangent, 0.559, gives me 29.2. That's my reference angle. So then I've got to go back and put it in the appropriate quadrants. So interestingly enough, this is a plus or minus. So think about that. How many quadrants is that going to go in, and which ones are we talking about? So if you think about it, it's going to end up in every quadrant, right? Because tangent is either positive or negative in every quadrant. So I need to put it in the first quadrant, I need to put it in the second quadrant, I need to put it in the third quadrant, and the fourth quadrant. And I did this in the introduction video as well, kind of reminded you about how this works. First quadrant is exactly what it is, 29.2 degrees. Second quadrant goes 180 minus 29.2. If I were to do that, I get 150.8 degrees. Third quadrant is 180 plus your reference angle. That gives me 209.2. And in the fourth quadrant, it's 360 minus my reference angle, and that gives me 330.8. So there's one that what you do when you're not on your when you get numbers that are not going to be on your chart. You've got to go back to what we learned in Unit 9 and find the reference angle and then apply it to the appropriate quadrants, whatever that might be. All right, here comes the last one. Last one, number 15, was the next one that I thought would be the hardest. And you look at this and you're like, that doesn't look very hard. You got cosines on both sides, right? But the problem is you've got a double angle mixed in there. And we talked double angles back earlier in this unit. So if you remember the double angle formulas for cosine of 2x, there were 3 choices. And so I've got to kind of come up with which one makes the most sense. So I'm looking over here at this that has cosine in it. One of the choices for cosine double angle is cosine squared minus sine squared. But then I'd have a sine squared in this whole thing that I'd have to deal with. And remember, we're trying to keep it to just a single trig function. So is there a cosine double angle formula that deals just with cosines? And there is. And here's what it is. This guy becomes, just for that piece, is 2 cosine squared x minus 1. That's what the double angle formula is that only has cosines involved for the cosine double angle. And then I'm just going to keep the rest of the problem the same. Plus 5 cosine of x. I'll bring the 2 over, minus 2. All right, let's see if we can combine terms here. So I've got 2 cosine squared x plus 5 cosine of x minus 3. And what I want to do is I want to go off to the side and think about factoring this. This would be equivalent to, if I were factoring back in algebra, 2x squared plus 5x minus 3. Except my x's are cosines, but really the approach is going to be exactly the same approach as what you did back in algebra. So let's see if we can AC method this. Yes, I know I'm going into number 16 here just for space, but here I go. 2 times negative 3 is negative 6. Factors of negative 6 that add up to be a positive 5 would be a negative 1 and 6, right? To get a positive 5. Divide by the leading coefficient. Simplify if you can. Go bottom to top. 2x minus 1, x plus 3. All right, let's go and apply it now with cosines. So over here, 2 cosine minus 1. Cosine plus 3. Solve them. 2 cosine of x, swing the 1 to the other side. Cosine of x, swing the 3 to the other side. Cosine of x equals 1/2. Cosine of x is negative 3. All right, so cosine of x equals 1/2. If I go back to, that's a number that's on my chart. So cosine is 1/2. And by the way, watch the directions, right? This one's in all solutions, and we do those in degrees. All right, so I'll talk about the all solutions in just a second. But I want to know where in degrees is the cosine equal to 1/2. So I go to cosine is 1/2 at 60 and 300. All right, so they're my two answers for this. X equals 60 degrees and x equals 300 degrees. If I come over to this one, cosine of x equals -3. Well, obviously that's not on your chart. But think about the cosine graph, right? The cosine graph starts here, goes like this. What's this top point on the cosine graph? It's a 1, right? What's the bottom point down here? This lowest point is -1. Well, is it ever going to hit -3 down here? And the answer is no, it can't do that. So this part alone gives you no solution. Not that the whole problem has no solution, but just that part of it. All right, then the second thing that comes into play is they want all the possible solutions for this. And remember how the wave keeps repeating and repeating and repeating. If I were to take this and keep repeating the wave, there's going to be multiple places where it equals 1/2. This is just what it is between 0 and 360. So I talked about this in the introduction video as well, that anytime you see, it's based off of the period of the graph. And we know that the sine and the cosecant and the cosine and the secant all have a period of 2 pi. Which is 360. And we also know that the tangent and cotangent, they're a little skinnier, their periods. It only takes for them 180 degrees, or pi. So what you need to do is just add on that multiple. Every 360 after that, it's going to repeat the same thing. Every 180 after that, it's going to repeat the same answer. So I go back over here, I'm dealing with cosine. And so if it's the cosine graph, cosine says to me I have to add 360s on. So it's plus 360 and any multiple of that, plus 360 and any multiple of that. I believe that the video might have used k's instead of n's, but I've always seen it at n's, so we're going to keep it as n's. All right, that should do it. So that finishes up section 11.5. You can email me with any questions. Thanks for your continued hard work. I miss you guys. I sure don't laugh as much without you all around. So take care and keep in touch, and I'll talk to you soon. Bye.